Hello, I would like to present to you Introduction to STM32 Model Zoo Services using as an example deployment of the AI model operation on STM32N6 microcontroller. I selected this microcontroller because it is quite powerful Cortex M55 based, extended with neural processing unit dedicated for the fixed point operations support. The STM32 Model Zoo Services, it is a GitHub repository and it contains scripts and application code to be used to ease development pipeline of AI models and then further integration on ST devices. There is another companion repository to the STM32 Model Zoo services, so-called STM32 Model Zoo, and this repository contains reference pre-trained deep learning models to be used with the services. So here you can see the block diagram of the showing interactions between those two repositories. The STM32 Model Zoo services can be considered as a kind of integrated development environment for your model development pipeline because it contains scripts and application code examples, embedded applications. You can provide your model, you can provide your data to be used with your model or to be used with existing model to train using your data. And the existing models can be found in the STM32 Model Zoo repository. Let me show you the Model Zoo services repository in the web browser. So this is the repository. You can clone this repository or just download zip file of the repository. Here you can see several AI use case-wise folders like image classification, object detection, etc. And also you can see application code, which contains source code of the embedded applications for various hardware platforms and supporting various use cases. Again, for example, image classification, object detection, etc. Coming back to the landing page of the repository and scrolling down, you can find description, detailed description of the repository, the list of the versions. The current version is 3.2, the description of the use cases, and scrolling down to the bottom, you can find important section before you start, where you can find detailed description how to prepare your environment, for example, Python environment. However, also Colab can be used. Let me show you the pre-trained models repository. It looks very similar to the Model Zoo services. Here you can see the folders of the Model Zoo services. Here you can see the folders of the Model Zoo. And the difference is that there is no application code. And in the use case-wise folders, for example, object detection, you can find the pre-trained models. Here you can see the various object detection models supported. Let's analyze, for example, Tiny YOLO-v2. Then you can find various use cases of the training using various data sets, for example, ST pre-trained model public dataset, COCO 2017 person dataset, and then you can find various input image resolutions supported, for example, 224 by 224. And finally, you can find Keras model. You can find configuration file. Let me open this file. I'm going to explain the content later on. However, this file automates training, quantization, evaluation, and benchmarking of the model. And finally, you can find quantized model. So this model, it is quantized version of the Keras model here. In particular, it is 8-bit quantization because our target hardware, it is STM32N6 microcontroller extended with the neural processing unit, and neural processing unit of N6 is based on the fixed point computations. In particular, 8-bit fixed point is supported. That's why the quantization is 8-bit. So here you can see supported operations of the STM32 Model Zoo services, so our integrated development environment for the models. So the training of the model operation is possible for both use cases: bring your own data or bring your own model. Evaluation of the accuracy of the model, both float and quantized, is possible. Quantization of the float model is possible. Prediction of the trained model can be implemented. Also, benchmarking of both float or quantized model is possible using selected STM32 target board. And benchmarking means evaluation of the inference speed or inference ratio in detections or frames per second. Then deployment on the target board is possible, and this is the subject of our course right now. And in order to add additional flexibility, you can perform sequentially more than one operation. You can chain the operations, like here, for example, the training, quantization, evaluation, and benchmarking is chained in one automated script. The target of our lab is to deploy object detection model to the target board. The target board, it is N6 discovery board. So let me show you the landing page. So as you can see, it is equipped with the 5-megapixel camera and LCD display. Then pre-train tiny yellow V2 object detection, person detection in particular model will be used. Let me show you how it looks like in the Model Zoo services structure. So what is important here, you can find STM32 AI _ main.py Python script. And this is main entry to execute your automated scripts to support various operations of the Model Zoo services. So in command line, first you need to call execution of this Python application and then point the path to your YAML script describing the operation of the Model Zoo services you want to execute. And also here you can find detailed description of the models. In our use case, it will be tiny yellow V2. And as you can see, this is lightweight version of the YOLO, optimized to be executed on the microcontrollers and say embedded microprocessors. Also here it is an opportunity to show you how to navigate within the documentation of the Model Zoo services. So now we are within object detection use case folder, and here you can find the docs subfolder, and in this subfolder you can find several README files describing all the operations like deployment, prediction, quantization, training, etc. And in our case, it is deployment. It will be deployment on N6 microcontroller. So we can open this README, and here you can find detailed description of the content of the YAML script. So the script describing the automated operation you want to execute. And also scrolling down, you can find the command line to execute your script. So as already explained, the main entry, it is a Python script, STM32AI_main.py, and then you need to give the parameter config path, and you need to point the path to your YAML script here. We are going to deploy a model on the target board. It means that an example embedded application must be used to execute your model. And as already explained, in the structure of the Model Zoo services, there is an application code subfolder. Entering this subfolder, you can find several use cases of the application code. We are focusing on the object detection. So entering object detection application code subfolder, you can find 3 supported hardware platforms: 87 microcontroller, STM32MP microprocessor, and STM32N6. We are focusing on N6 right now. So entering this folder, you can find the content, and in particular, we are interested in model folder here. And here in the model folder, we can find 2 models. The default one, it is STYolo-X, and the model we want to deploy, TinyYolo V2. So within the model subfolder of the object detection application code use case, you can find this content. And we are going to deploy the quantized TinyYolo V2 model. What means that we are going to update an example embedded object detection application to be executed on N6 microcontroller with this TinyYolo V2 model. And to remind you, the quantization applied for those models is 8-bit because neural processing unit of N6 microcontroller supports fixed point, in particular 8-bit fixed point computations. Here you can see simplified block diagram of the object detection embedded application. So the 5 megapixel camera is connected to the board using CSI serial interface, and 2 pipes of the camera are used. The first pipe 480 by 480 is continuous to show live video stream on the discovery board display, and the second pipe provides input images, provides snapshots. Resolution is 224 by 224 because we are using such a model. Here you can find 224 indication in the model. And the live stream video is stored in external RAM memory, while the snapshots for the object detection model are stored in neural processing unit dedicated RAM because of the much higher bandwidth than external RAM, what of course accelerates the execution of the model. And the network data, the weights of the model are stored in external flash. Then, after execution of the models, output is post-processed and we have layers blending, and finally we can see the result on the screen. Blending is needed because we need to blend the live video stream and frames to show the detection of the objects.